Okay, well, let's use reduced row echelon form to solve the system here. So first thing we want to do is we want to rewrite this using an augmented matrix. So we're going to rewrite this, right? So we're just going to take all the coefficients of all of our variable terms and then the constant. We're just going to put them all in an array here, right? So we've got a 1, -2, 3, and a 7. So we got 1, -2, 3, and a 7. Okay, we got -3, 1, 2, -5. So -3, 1, 2, -5. 2, 2, 1, 3, 2, 2, 1, 3. Okay, so put our little square brackets on there, and we've got our line separating our constant terms from our variable terms. Okay, so we want to use reduced row echelon form. So our goal here, oh man, that's so convenient right away. Our goal here is to get ones on this diagonal, and man, that's so convenient that they're already there. But they're going to go away, so we'll see what happens. We want to get ones on the diagonal and zeros everywhere else here. So I want a 0, 0, 0, 0, 0, 0 in all those positions. So we want to be really, really systematic about this. So every time we do the same thing. First thing we're going to do is we're going to make sure we get a 1 in this position. And we do, so that's great. Now after we have that 1 in that position, we're going to use this 1 to cancel out everything below it. So I can take this 1 and I can multiply and add these rows together. So I can take, for this first step, let's do 3 times row 1, and we're going to add that to row 2. And we're going to put that in place of row 2. And we're going to do the same thing here. We're going to do -2 times row 1 plus row 3, and we're going to put that in place of row 3. Okay. So we're doing two things here. We're just going to be eliminating those two numbers there. So we're not doing anything at all with that first row. So I got 1, -2, 3, 7. That doesn't change. But these two rows are going to change. So I'm going to do, for row 2, I'm going to put 3 times row 1 plus row 2. So 3 times row 1 is 3 times this position plus this position. So 3 times this position plus this position, right? And so on down the line. So 3 times 1 is 3 plus -3, that's 0. So that's, remind yourself that that's what you wanted to do. So this is the right thing. So we go down the line and we take 3 times this position and we add it to this position. So 3 times -2 is -6, plus 1 would be -5. Okay, so then we would do the same thing. 3 times this one is 9. 9 plus 2 is 11. All right, and then we do 3 times this one, which would be 21, plus row 2, so that's 21 minus 5. So what is that, 16? Okay. So onward, we do the next one. We will do -2 times row 1 plus row 3. So -2 times row 1 would be -2, plus 2 would be 0. That's good. And then we would have -2 times this one would be 4, plus this would be 6. Okay. And then -2 times this one would be -6, plus 1 would be -5. All right. -2 times this one is -14. Plus 3 would be -11. All right, put a little line there. Okay, so good. We're almost in good shape here. So now what? We want to get a 1 in this position now, right? So it seems like the easiest thing that we can do in general would be to take this and just divide that whole row by 5 or -5, right? Because that's going to leave you with a 1 there. But what if we don't do that? What if we add 2 rows together? Well, if we just add row 2 and row 3 together, I'm going to have a 1 there, right? So that'd probably be easier, and it would give me less fractions. We're going to have to deal with fractions eventually here, probably, but if we can avoid it, we kind of want to do that. So let's replace row 2 let's replace that with row 3 plus row 2. And that's all we need to do right now. So let's leave row 1 alone. So we got 1, -2, 3, 7. And I'm just going to put, instead of row 2, we're going to put row 3 plus row 2. So add 0 plus 0, that's 0. -5 plus 6, that's 1. 11 plus -5, that would be 6. And then add these together, we get a 5. Okay, and then we're going to leave that one be. So 0, 6, -5, -11. Better line. All right, cool. Now we have a 1 there, and that's good. That is, we're in good shape, because now we can use this 1 to cancel out these guys, right? So I can take, because there's a 0 in this position, anything I do to either, any multiple of this row is going to have a 0 in that position automatically, right? Because it's already a 0. 0 times any number is always 0. So anyway, we can do the next step. So we're going to eliminate these two guys. So we want to do 2 times row 2 plus row 1, and we're going to replace row 1 with that. And then we're going to take row 3, and I'm going to take -6 times row 2 plus row 3. I'm going to put that in place of row 3. So this is going to get rid of our 2 here. It's going to get rid of our 6 here. All right, so row 1 is getting replaced with 2 times row 2 plus row 1. So 2 times 0 plus 1 would be 1. 2 times 1 plus 2 times 1 is 2, plus -2, that's 0. So we got a 0 there. So that did what we wanted. 2 times row 2 is 12 plus row 1. So 12 plus 3 would be 15. And then we've got 2 times row 2 is 10, plus 7 would be 17. Okay, and now row 3 is the next one we're going to change. We're not changing row 2. We're leaving that be. So I got a 0, 1, a 6, and a 5. Okay, so now we're messing with row 3. So I've got -6 times row 2. So that's -6 times 1 is -6 plus, right? We're going to have a 0 and then a 0, right? 0 times 2 is 2, or 2. 0 times 2 is 0, plus 0 would give you 0 in that position. Okay, so we got -6 times row 2. We've got those taken care of. -6 times row 2 would be 36, plus row 2, or excuse me, plus row 3. So I've got 6 times this one, negative, would be -36, minus 5 would be -41. Oh my. Okay, so then what? We got from the last position here. So I've got -6 times row 2. So that would be -6 times 5. That's -30. Plus -11 would be -41. Holy buckets. I was a little worried there for a minute, but this is going to work out just fine. Okay, good. So now we have a 1 in this position, 0's below it. 1 in this position, 0's over there. And now we want a 1 in this position and 0's above it. So we can do that one pretty quickly, and we'll see really quickly also why I was kind of relieved here. So I want to do now, I want to replace row 3. I'm going to replace that with 1 over -41 times row 3. So I can just say, hey, I got a 1 and a 1, right? That's super convenient. Or at least more convenient than I thought it was going to end up being. 0, 1, 15, or excuse me, 1, 0, 15, 17, 0, 1, 6, 5. And then I'm going to have 0, 0, 1, 1. Oh, wow. And now we're essentially finished here, right? So we just have to take our 1 and cancel those guys out. So we can do that. We're going to replace row 1 with -15 times row 3 plus row 1. We're going to replace row 2 with -6 times row 2. Excuse me, row 3 plus row 2. Okay, and that's going to get rid of all of our variables we don't want. Okay, so in the top, the first row, I'm going to do negative 15 times row 3. So that's, both of these are 0, so I'm just going to have a 1 and a 0. And then I've got negative 15 times this guy plus this guy, that's a 0, good. Negative 15 times 1 is negative 15 plus 17 is 2. All right, that's cool. And then my second one, we've got negative 6 times this would be 0. Right, this is staying the same, this is staying the same, because 0 times anything is always 0, so I'm just adding nothing. So negative 6 times this one, plus this one would be 0. Negative 6 times this one would be negative 6, plus this one would be negative 1. And we are finished. So this is now reduced row echelon form. We have 1s on the diagonal. There they are. And we've got 0s everywhere else. So when we translate this back from a matrix back into a system, if we really wanted to do that, we would write the system like this, right? We'd have x, right? We remember this is x, this is y, this is z, and this is our constant. If we wanted to, we could write x equal 2, y equal, right, because that's y, negative 1, and then z equal 1. And we're finished. Or, you know, we could write it as an ordered triple as well, right? 2, comma, negative 1, 1. I ran out of room on the sheet of paper, so wrote it over there. How wonderful.